Okay, this is one of those cases where you're two derivatives in, so you have to integrate. You have to go backwards two integrations to get it back to the original, right? Because to have the second derivative, it means somebody took the first derivative and then the second derivative. So you have to unravel that 2 units going backwards, right? You have to unravel that 2 processes going backwards. So for instance, if I integrate the second derivative, that will undo one of the derivatives because you're going the other direction. So I'm going to integrate the second derivative. Just remember to pull it up when you do that. And right, so what I'm doing here is we just said this is going to end up giving me the first derivative when you integrate the second derivative. Alright, so let's go ahead and integrate it. So you add 1, it makes a -1, divide by -1, and then we write C sub 1 because we're actually going to find out the particular solution here. Alright, so this is the first derivative. Let me just format this first. Okay, that comes down. The negative, I prefer to bring it up. So we have this. Now the idea, let's use this piece of data right here. So it says if I plug in a 1, this should equal to 1. So if x is 1, this should equal to 1. So if I let x equal to 1, this has to equal to 1. So -2 plus c sub 1 equals to 1. Move this to the other side. So c sub 1 is 3. So right now you have that the first derivative is equal to -2 over x plus 3 because you just solved for the c sub 1. So they're giving you these specific data points so that you can solve for the c values. Alright, now just like I explained over here, if you integrate the second derivative, it takes one of the derivatives off because you're going in the opposite direction. It like counterbalances. Like if I took two $5 away, if I integrate, I'm going the opposite way. It means I would have given one back, given one $5 back, right? You're going the opposite. So if you integrate the first derivative, that's going to give you the original function, which is what we're looking for. So I'm now going to integrate the first derivative, and I'm going to write this a little, you can leave it like that, but I'm going to write it -2 times 1 over x, because I think people see that a little bit better. This is the same thing, but I just think you're going to, some people see that a little bit better. Because what happens is when you integrate this, when you integrate 1 over x as ln of x, you can put the absolute values if you want, and it's got a -2 in front, so it's negative. So like if I took the derivative of this, it's that. For sometimes it's easier to go backwards. This derivative of this is that. So this is a derivative of ln of x, just got a multiplier of -2 on it. And if we integrate the 3, that's 3x, right? If you go backwards, the derivative of this is that. And then just don't forget, now you're on your second c value for this problem. Alright, so now you got to find c2. Just to find c2, you're going to use this value. When x is 1, it should output 1. So I'm going to now do that. I'm going to let x be 1. And this whole thing has to equal 1 when I put in 1. ln of 1 is 0. So 3 plus c sub 2 equals to 1. Move the 3 to the other side. So c sub 2 equals to -2. Now let's just put the whole answer together. So the final answer here will be this, but we're just going to let the c sub 2 be a -2. So the original function was -2 ln x plus 3x, and we just solved for that last constant to be a -2. So this right here is actually the final answer. Alright gang, that's it on this one. Catch you.